All right, let's continue in chapter 2 here, and let's talk about protons, neutrons, electrons a little bit deeper, and these things called isotopes. Okay, in the periodic table, or on the periodic table, we're going to see a little block for each element. And depending on the periodic table that you have, the information that's in that little block is going to be a little bit different. So almost always there's a number on the top, a whole number. The symbol is almost always there, and then this number on the bottom, which is decimal, which we'll talk about here in a little bit. Okay, sometimes the name of the element is also there. On the periodic table that you'll have for exams, the name won't be there because you need to know the names. All right, so let's go through what each of the things on this little block means, what information it gives you, and so on. So first, this number that's on top, it's called the atomic number. And the atomic number is the number of protons in an atom of that element. So for example, gold atoms have 79 protons. Every gold atom has 79 protons. So the atomic number gives you the identity of the element of the atom. Okay. If you look at the periodic table, it's in order of atomic number. In the upper left-hand corner is hydrogen, which has atomic number of 1. Hydrogen atoms have 1 proton. And then it goes down to the bottom right, where it's 118. Okay, and then everything in between. But it goes in order from left to right, top to bottom, by atomic number. Okay. The other thing, if we recall, that atoms are neutral. And for atoms to be neutral, that means they have to have the same number of positive charges as they do negative charges. And since protons are positively charged and electrons are negatively charged, atoms have to have the same number of each of protons and electrons. So in an atom of gold, there are 79 protons and 79 electrons. All right. Let's move on. Okay, so we have this other thing called mass number. And then a mass number has nothing to do with, it's not on the periodic table. Okay, that decimal number, this thing, is not the mass number. When we say number, that means a counting number, an integer, a whole number. Okay, atomic number, 1, 2, 3, 4, 5. Okay, the number of protons. Mass number is going to be the number of protons and neutrons in an atom. So it's the number of particles in the nucleus, right? Because the nucleus has the protons and the neutrons in it. So the mass number is the total number of protons and neutrons in an atom. All right, so we said that the atomic number is the number of protons, and it gives us the identity of the atom. Okay, so the number of protons and the number of neutrons is going to give us what's called the isotope. Now, different elements, atoms of the same element, for example carbon, are going to have all 6 protons because the atomic number of carbon is 6. That means every carbon atom has 6 protons, but carbon atoms can have different number of neutrons. Okay, neutrons are neutral, so they don't affect the charge. They don't affect the number of electrons. They're just in the nucleus, and there's reasons for that, but we're not going to get into it. Okay, but the mass number is the number of protons and neutrons in the atom. So if we can see here, carbon 12, where we name the atom by the mass number, because that's the thing that can change. A carbon 12 atom has an atomic number of 6 because it's carbon. All carbon has atomic number of 6, which means it's got 6 protons. But if the mass number is 12, and that's the protons plus neutrons, that means there must be 6 neutrons also, because 6 plus 6 is 12. Okay. When we write proton, the symbol for proton typically is P with a plus charge as a superscript. And neutrons are either N by itself or N with the superscript 0 because neutrons are not charged. They're neutral. Okay? Carbon-13 atoms, atoms of carbon that have a mass number of 13, have 6 protons because all carbon atoms have 6 protons, but 7 neutrons. So for a total mass number of 13, right? Because protons plus neutrons is the mass number. So atoms of carbon that have a mass number of 13 have 6 protons and 7 neutrons. Okay, carbon-14. Again, carbon, it's got 6 protons in it, that atom, but now that's got 8 neutrons because 14 is the mass number. That's the number of protons plus neutrons. Okay, and if we're talking about atoms, all of these would have 6 electrons because atoms are neutral. Okay. And typically we'll write electrons with an E with a negative charge, a negative sign as a superscript because electrons are negatively charged. All right, so isotopes are atoms that have the same number of protons but different number of neutrons. Okay, so they must be of the same element because they have the same number of protons. So isotopes are atoms of an element that have different numbers of neutrons. Right? We can say this in a bunch of different ways. We can say isotopes are atoms that have the same atomic number but different mass numbers, same number of protons, different number of neutrons, however you want to say it, but that's what isotopes are. They're atoms of the same element that have different numbers of neutrons. Okay? And isotopes of an element all react very similarly. The neutrons don't affect much. They add a little bit of mass, but not a lot. And basically every element has different isotopes. All right, so we can write isotope symbols in different ways. Sometimes we'll write it with the name, with a dash, with the mass number, so carbon-12. Where the mass number is 12, that tells us we've got 6 protons and 6 neutrons. Sometimes we'll just write it with the symbol of the element dash the mass number. And then a really common way to write it is like this, where you have the symbol of the element. In the bottom left-hand corner is the atomic number. And sometimes that's not put there, because we already know what the atomic number is because we know what element it is, right? Because we have the elemental symbol. It's carbon. Carbon atoms have 6 protons. In that upper left corner, that's the mass number. So when we're dealing with isotopes of elements, we can provide their name, carbon-12, or their symbol plus their mass number, C-12, or we can provide this, what we call a nuclear symbol, because it tells us about the nucleus, right? It's got the number of protons, and it's got the number of protons plus neutrons. It tells us all about the nucleus. So that's why it's called a nuclear symbol, right? So carbon-12 would have a symbol 12 in the upper left corner, 6 in the bottom left corner with the capital C. Carbon-13 atoms with 6 protons, 7 neutrons would have a symbol that looks like this. And carbon-14, carbon atoms that have 6 protons and 8 neutrons. Okay. The other thing that's on these blocks of elements is that decimal number on the bottom, and that's the atomic mass. It's not atomic number, it's not mass number. Those are whole numbers, those are counting numbers, okay? It's the atomic mass. And the atomic mass is the average mass of all stable isotopes of that element. Okay, so for example, if I'm dealing with chlorine, chlorine has 2 stable isotopes. And what I mean by stable is that they're not radioactive. They don't decay, they don't break down. Okay? Chlorine-35 and chlorine-37. are stable isotopes of chlorine. Question is, how many protons and neutrons are in each of these? Well, if we look at chlorine at the periodic table, it has an atomic number of 17. So we would have, so chlorine 35 would have a little 17 down here and a 35 up here, and chlorine 37 would have a little 17 down there because it has the same atomic number, and 37 up here. So for chlorine 35, there are 17 protons and 18 neutrons. In an atom of chlorine 37, there's 17 protons and 20 neutrons. Okay, if I look up information about the isotopes of chlorine, I can see that chlorine 35 has that mass, and its abundance, meaning that if I take a bunch of chlorine atoms, if I look at a bunch of chlorine atoms, 75.76% of them would be chlorine 35. Those atoms would have 17 protons and 18 neutrons. And then 24.24% would be chlorine 37. Okay, so basically it's a 3-to-1 ratio, right? For every 1 chlorine 37, there's going to be 3 chlorine 35s. To calculate the atomic mass, it's the average mass of all stable isotopes of chlorine. So if I collected all chlorine atoms and took their average mass, that would be the atomic mass. And to calculate the atomic mass, we use both the mass of the isotope and the abundance of the isotope. So we take the mass of the isotope and multiply it by the abundance of the isotope for each of them, and then we add them together. Okay, so for the atomic mass of chlorine is the mass of the first isotope times the abundance of the isotope in decimal form, not percent. So basically we divide the percent by 100. Right, to get to 100, to get to percent, we have to multiply the things by 100. So that means if we got the percent sign, if our abundance is in percent, we have to divide that number by 100. So 75.76% is 0.7576. And then we take the second isotope, Cl37, we take the mass of the Cl37 and the abundance of Cl37. So we multiply the mass times the abundance of the first isotope and the mass times the abundance of the second isotope, and I get that and that, and then I add them together and I get that. So if we look at the periodic table, we should see the atomic mass of chlorine, the number on the under Cl, is 35.45, and I have a periodic table hanging over there. I'm going to look real quick, and it has 35.45. Okay, so the atomic mass is the average mass of all stable isotopes of an element. And we calculate that by taking each isotope, the mass times the abundance of the isotope for each of them, and then adding them together. Chlorine was nice because it only has 2 stable isotopes, but there are elements that with 5 or 6 stable isotopes, we would do the same thing. Take the mass of each isotope and multiply by its abundance, and then we just add all those together. Okay. So I've got a little practice for you now. So that means we should pause and run through this. If you're having trouble, unpause and let me do one for you, and then you can pause and try the rest. Okay, so pause now and see what you can do. All right, so you either come back because you're stuck or you're done. So let's run through this. Okay, so we have the symbol for each element we have here. In this case, we have Ne, which is neon, 10, 20. Remember, 10 is the atomic number and 20 is the mass number. The atomic number is the number of protons. The mass number is the number of protons plus neutrons. Okay, so the atomic number is the bottom number, so this is going to be 10. The mass number is the top number, so that's 20. Remember, the atomic number tells us the number of protons. And since we're doing atoms, the number of protons and the number of electrons have to be equal to each other because it has to be neutral. So the number of electrons also has to be 10. The number of neutrons we're going to determine from the mass number. So the mass number is 20, and we said the mass number is the number of protons plus the number of neutrons. So if the mass number is 20 and we have 10 protons, that must mean we have 10 neutrons, because 10 plus 10 is 20. Okay? Remember, mass number is the number of protons plus neutrons. So protons plus neutrons is 20. All right? Next one, atomic number 13. If we look at the periodic table, that is aluminum. So I'm going to write Al here. And we know the atomic number is 13. We still have to figure out the mass number, and that's going to go up there. Okay. What does the atomic number tell us? It tells us the number of protons. So that must be 13. And since this is neutral, we're assuming everything's neutral, it's also the number of electrons. So the number of protons and electrons are the same because atoms are neutral. Okay, mass number is protons plus neutrons. We have the number of protons and the number of neutrons. 13 plus 14 is 27. So remember to also write that in your symbol. Okay, so this aluminum atom has a mass number 27. That means it's got 13 protons, 14 neutrons, and then 13 electrons. Okay, next row. We have a mass number of 54 and a number of protons of 26. So number of protons and number of electrons are the same. The number of neutrons is going to be the mass number minus the number of protons. So 54 minus 26 is 28. So there are 28 neutrons in this atom. The atomic number is the same as the number of protons, which is 26. So if I go to the periodic table and look at for number 26, I can see that it is iron, Fe. And we're going to put the atomic number down here and the mass number up here. And that's our symbol. Okay, keep going. We have number of neutrons and number of electrons. So the number of electrons is the same as the number of protons, 42. The mass number is the number of protons plus neutrons. So 42 plus 33 is 75. Number of protons is 42. 42, the element is molybdenum, Mo. That's not one on your table, but we can look it up on the periodic. That's not one you have to know, but we can look it up on the periodic table, Mo. And the number, the atomic number is 42, and the mass number is 77. Oops, 75. Shoot, that should be 75. Because 75. Okay, keep going. Atomic number 47, mass number 107. If you look at 47, that is going to be silver, so Ag. So if our atomic number is 47, what else is 47? Protons, right? And electrons. And then our number of neutrons comes from the mass number, because mass number is protons plus neutrons. So 107 minus 47 is 60. So there's 60 neutrons. Our symbol is going to have Ag. 47, which is our atomic number, goes in the bottom left. And our mass number, 107, goes on top. All right, last one. Number of protons is 50. So that means our mass number is 50. And our number of electrons is 50. The number of neutrons is 67. So our mass number is going to be 50 plus 67, which is 117. Atomic number 50 on the periodic table is tin. Tin symbol is SN. So it's going to be SN 50 117. That's how you do those. Number of protons and number of electrons are the same in a neutral system. The atomic number is the number of protons, so that also gives you the number of electrons. And then the mass number is protons plus neutrons. Okay, last thing is calculating the atomic mass of this element. Okay, this element has 4 stable isotopes. So to calculate the atomic mass, we have to take the mass of each isotope and multiply by the abundance, so 49.946 AMU times our abundance. Remember, we have to divide by 100, 0.04 up to 345. Plus, we do the next one, 51.940 AMU times its abundance, 0.8379 plus 52.941 AMU times 0.09501, and then the last one plus 53.939 AMU times our abundance. We got to divide by 100, so 0.02365. Okay? So I'm going to multiply each of the mass times the abundance. So 49.946 times 0.04345 gives me 2.170. So if we're doing significant figures, we should have 2.170 AMU. Well, we shouldn't round yet, so let's do that again. So this will be 2.17015 plus 51.940 times 0.8379, 43.5205. Why does it keep doing that? 43.5205 AMU plus our third isotope, 52.941 times 0.09501. So 5.02992 AMU plus 53.939 times 0.02365 is 1.27566 AMU. So now we just add those all together. 2.17015 plus 43.5205 plus 5.02992 plus 1.27566. I have 0.99626 AMU. Should have basically force them in figures. So 51, so 1, 2, 3, 4, 6 goes, rounds up. So 52.00 AMU would be my atomic mass of this element. It asks what could be the identity of this element. Looks like it could be chromium. Cr, chromium. If you look at the periodic table, the atomic mass is 51.996, which rounds to 52. Right? So hopefully you understand this. If not, get a hold of me and we'll figure out where you're struggling.